So on top of all that, please make sure that you have wherever it disappeared to. Homework written down for tonight, 6 through 10. Bless you. You allergic to math? What did math ever do to you?
I don't like math.
All you have to say. I get it.
Guys, I get some of you are busy. This is why I would never do the chapter test today. Like the day after assigning closure. I want to give you time to take care of things. I was at your choir concert last night. You're one of our friends from choir. Like, I get it. You're busy. This is not, like, as I walk around and look at stuff, don't hide things. But if you're not done, that's fine. I just want to know if there was anything you couldn't solve. That's what I'm here for. Yeah.
I got this by guessing, and I guarantee it's wrong.
Oh, did you? The answers are in there to check. So you can either know it's wrong or know it's right. But okay, what question? 3-134. I bet you, when I lay this out, it'll make complete sense to you guys.
I know. This was hard. I didn't do it last night.
Anybody who are really confident in how to explain it? You have the look. You have the look. Come on. You're good.
I think it's wrong.
Oh yeah. The board is yours. You own it.
What happened to the markers?
They're all there. What do you mean?
We switched them.
So the blue marker has a really mashed-in tip, and therefore doesn't write very cleanly. So I just grab whatever marker, and then I switch colors up here. So if you want to change colors, you have a whole palette of colors.
Okay, so like there was the first one, and it had the 5 and the 2 separate ones. Like this is the one.
What do we need to realize about the 2 tightropes first? Anybody?
1, 5, and 1 is equal to 4 and 10.
Well, okay, so first, you jump past even the first thing we realized. They're the same length, right? Which is, so you made that inference in what you said. Then if you chop an M off of both of them, they're still the same length. 1, 5, and 1 is the same as 4 and M. What's 1, 5, and 1?
7. 4.
So was that how you solved it, by chopping an M off?
Yeah.
No. Well, I knew that they're the same length, and I just had to figure out a number would make them both the same.
Yeah.
And 3 would, because it'd be 6 here, and then there's 10, and that'd be 10.
That's perfect. So this turns into, sorry, thank you. This turns into 7, what you guys just said, and M if I don't take it off, if I keep it there. This is 4 and M and M. And then I can just play with it. If I don't see a good way to solve it, try 1. Doesn't work. Try 2. Does it work? 9. 8. No. Try 3. 10. 10! And it works. But another way to do this is chop off one of the M's. Don't think about that. And think just about this section. That's another way to do it. Look for what's common to make your life easier. Other questions from last night's group? That's how you ride your horse. It's also just how I kill time. Anybody? Percussion. Yeah.
It's about writing it down, though. I understood it, but it was not writing it down.
Which question?
131, where it says
Pretty
simplify. Wait. Yeah.
All right. So now, bring it down.
Simplify the expressions. Are we supposed to write the answer or every single step we did? Because I wrote every single step I did and did that.
Yes. Correct. So when it says simplify, you want to get to the simplest way to express it. No operations left to do, nothing. And really where this comes in is when we will start to have unlike terms. So if this expression, instead of having negative 2 times negative 5 plus 7, was negative 2... I don't even know how it used highlighter over here. If it was negative 2 times z plus 7, and I do the multiplication and I get negative 2z, can I add something that I don't know with something that I know? No. So we'd be stuck here. Right now, we're not, though. Because right now, we know that our multiplication is actually positive 10. So we can rewrite that as positive 10 plus 7, and then rewrite that as 17. Now, I would encourage you to work these all vertically, and the main reason why I say that is for the complex problems that take a lot of steps. Now, by that, it doesn't mean like moan and groan and decide you don't do it. You can get through most of these problems quicker than you can complain about them. You guys take a long time to complain about things. 3.71. So if I'm doing C here, plus, and actually this probably isn't the most complex one here. B's pretty, B and D are both pretty complex. What's a parenthesis right up against a parenthesis mean? Multiply. When I'm working within parentheses, how do I work it? Because I know parentheses come first, but so I've got multiple parentheses here. How do I work this, Piper?
For the parentheses, if you have two sets, like you're ignoring the substance and parentheses, you go left to right. Like no order if you have parentheses. So you start with the farthest one to the left, and you do that operation. And then
Yeah,
the other one.
I agree with most of that. We don't always strictly work left to right. We work from the inside out while working left to right. So I agree with working left to right. But when I'm in a parenthesis, especially like working with D, I solve in the parenthesis as I work outward, because if I'm working left to right and I haven't solved in the parenthesis, I can't deal with it. So solve within the parentheses, then work it across. Here, use a calculator if you want, but we can think it through. Same team, different team.
Different team.
They're going to join up or fight?
Fight.
Fight. So we are finding a difference. Who's stronger? The
The
negative. So we get negative something there. Probably 1 point something.
Negative 1.5. I mean, yes, negative 1.54. I think.
And then who wins?
Negative.
Negative times a negative? Positive. A little over 7.5 probably.
It's 7.7.
5. Something close to that, yeah.
Yes, it is.
7.5. No,
It's in your book, dude.
No, it's 7.7 because it's
oh yeah.
5. That's 5 times 4 is 0 plus 5.
Yes, you have the answer. I was on the page after. Which one was this? 131?
No, 7.7.
7.7. And they may have rounded, but 7.7 is what the book has.
So I was right. I did that in my head. I was right.
Other questions from the book? Is that yes? Cool.
I still don't get 134. How do you
134,
just like
okay.
take away the M and then?
I'll do it another way. So, there are a lot of ways to solve this problem. I'm going to show one that's a bit more in-depth. Okay. So what's hard here is we already actually know what M is. So I'm going to take a couple liberties already knowing what M is. So if we say we're going to span some distance, and one way to span it is going M, then going 1, then going 5, and then going 1. Or another way to span that same distance is going M, then going M, then going forward. Gets me the same distance. That M is like a leap or a jump or whatever you want to say, some unknown distance that we went. We know that they're equal. Mathematically, I could then write that as M plus 1 plus 5 plus 1 is equal to M plus 4. Are we with me on that?
Yeah.
Then, wait, somebody say no?
No, I said yes.
Wait.
Hmm?
Which one are you doing this? No. Okay.
That's
Okay,
both.
okay,
Top
okay.
one equals the bottom one. So they're equal to each other. I don't know how long they are, but they're equal to each other. Hold on. So this comes back to the simplify step. What can be combined over here? The 1, 5, and 1, the numbers, right? So now I have my unknown and 7. What can be combined over here, right?
You don't have to. You can keep it this way, but you can make it multiplication. You can do 2m.
Yeah, I can combine these and say if I have an M and another M, I have 2 M's.
Which can make it convenient to figuring out the other one because you just figure out what first one could be then.
So, now this gets to a point where the algebraic solution process that we don't expect you to know yet, but would be very, very useful. If I have an equation, I can do absolutely anything I want, as long as I keep it balanced, right? Because I cannot get this unbalanced. So I am going to start doing some stuff to both sides, like when we had our number tiles. What could I do to start to make things easier and work towards the end goal of M by itself somewhere? I don't care what side it's on, but I need M by itself. Moving dear? This M, or these 2 M's, have a 4 with it that we don't really want with it. And if I think about the tight ropes, if I just get rid of that length, come on, touch what I want. If I just get rid of this, all I've got are my M's. Now, inconveniently, that doesn't line up quite right, but I could move some things around and make it. So I just say, all right, take the length of 4 off both sides. Now, my left side, or that tightrope, is M plus 3. And my right side, 2M. No, wait. If M plus 3 is equal to 2M's, and we know this 2M was really M plus M, M plus M, M has to be 3. But if we don't yet see it here, I can either think through how do I get M by itself. I'll take away 3, but I can't. And I can't take away 3 over here. So how do I get M by itself? Take away M, right? If I still had 2M, it would be divide by 2. That would be our process. But we don't really want to divide, and again, we'll get deeper with the algebra later this year. If we divide, that makes this very tough. That would make this very hard. But taking away an M is easy. So forget about that option. Take away the M, take away the M. We get 3 is equal to M. That's enough. That's the strictly algebraic way to solve it. Does that make any sense? Okay. So we can always do anything to equations as long as we do the same. I don't know why I'm out of breath. Questions? I get really excited on some things and I like hold my breath when I'm trying to I don't know. Just keep the I don't know I'm weird statement as like just a disclaimer for everything. I don't know.
We're all good.
Other questions from closure? No.
You can just say, I don't know, I just didn't do it.
That could be like an answer for why'd you do your homework in 7 different colors. Which I had a girl once do every problem in a different color until she cycled through her colors and then started over. Because she had like the gel pens and really loved them. And it was sweet. I mean, like, her homework was fun to look at. Yeah.
My sister got like they're allowed to use like a cheat sheet card on a
Yeah.
really big test, and so she wrote really small, but to distinguish every different fact, she used different colors and then cycled.
I've done that before. Yeah, so it clues your brain in.
His teacher wrote on some of his papers with red pen. He had such fast too deep. He whited it out what it was, wrote it in black pen. Because he had such fast.
See, and I don't like red. I don't grade much with red pens. I just have all kinds of different colors. So like red, we want to like get rid of colors meaning certain things, unless you're using them for like math coding. But you should think just about like colors being coding, not that red is bad. Alright, so we're flipping to 411. You got a lot of wait time to ask questions if you felt like it. You guys like figs?
I like big pots.
You love figs, right? All kids love figs. Right? Like fig Newtons. Kids are always like figs and like fig Newtons. Like, oh, figs? A fig is a type of fruit. But the reason I bring this up is today is 1010. Our topic, bring it in, please. We're starting chapter 4 now. And we're talking about similar figures. Now, why I brought up figs, some people abbreviate this sim, not sin, sim fig. Not that your fig is living in sin, but that it is similar.
Or that
Now,
figs and cysts.
what does it mean to be similar? So like if I say, like, my brother is similar to me, or like Alex,
It means to have things in common.
yeah, does it mean to have everything the same? No, so some things are in common, some things are different. What were you going to say, Piper?
Partially equivalent.
Partially equivalent. I like that. That's big words. I try to avoid big words when possible. Partially equivalent. So, in 4-1, we need that dot paper that if you did not grab as you walked in is on the back page. If you grabbed a card, yeah, you all need a sheet. If you grabbed a card, you should have seen that, hopefully. And we are going to start helping Karen. So Karen is learning how to use a copy machine, and playing around decides. What was? You sounded sad. Not yet. I mean, yeah, actually, that happens. So I guess I should read our intro paragraph. So today we're going to extend our study of ratios by looking at enlargements and reductions of geometric figures. I don't know exactly why we say geometric, because everything we work with this year is really geometric. Well, I guess if you make like a really awkward figure, it might not be geometric. But what we're working with, they're geometric. Think of a copy machine and what it does to a picture when the enlargement is selected. So, wouldn't it be really awkward, and we had this issue with Pearson, if when I zoomed in, things got wider but they didn't get taller? Or as I zoomed out, if they shrunk height but they didn't shrink width? It starts to look really weird. What do we call it when things keep the same look even though they change size? Piper?
I don't know if they're like equivalent or equal.
Careful. Not equal, not equivalent. Oliver said it. Scale. Something is too. In order to make a scale model, like a scale model car, model plane, scale tells you.
There's the scale button, and so it just shrinks it down.
Scale tells you what multiplier would be needed to get back to the original, or what got us to the scale. Yeah.
Like when you use a microscope, so you have to like write down how much you zoomed in.
Yeah, so if you were like 10x or 100x or 1000x, that would be like the scale of what you're viewing compared to what it actually is. So, dive into 4.1. You've got dot paper, you've got some instructions. I want to see how we do, and also test out these new teams. Now, if you think you're going to forget who's on your team, jot down your team names really quick. So that, I would advise that you guys just stay seated where you are, unless like if it's hard for you guys to see the board. I think I moved the desk well enough, but if you want to move to there, you could, but that's up to your team. Let's take a few minutes on this. We'll take at least 3. So I'm going to leave some of this in the back of the room. This is isometric dot paper. You right now are using what is just known as standard graph paper or like orthographic dot paper. It's all squared. If you want to give perspective, isometric dot paper is how you can draw 3D drawings. I'm just going to leave some back on this back desk if anyone wants to play with it later. Not now, later. Later. Not now. Later. If I went to Willy Wonka's factory and he now, beyond the fizzy lifting drink and everything else, has a drink that will, we're going to call it scale soda. Right? So I drink some scale soda and I take 1 sip and he's like, oh, well, that will keep you the same. I take 2 sips and it gives me 200%. I take a 3rd sip and it makes me 300%. What? Now, wait, because I don't want to break out of this building. So if I am 300% of what I started at, what would have happened to my feet?
It would have gotten 3 times. It would have been, the size of the feet would have been 3 times.
So what's another way we can say 3 times?
Triple.
It's
Triple, right? Like that triple double stacker or whatever thing. So triple, right? What would have happened to my arm? What happened to my head? So if any part of me triples, then all of me would triple. Or I'd look really awkward, right? If one arm like stays how long it is. So be careful. As I walked around, I saw some errors. If my length triples, my height triples, every piece of it triples. Check it. Check each other too. Now be careful, the diagonal distances are not counted as 1. Hey, let me make something very clear. Well, not quite. Let me make something clear really fast. This is not 1. That is not 1. Hold up. Hey, give me your attention. Stop working. We're not trying to finish this lesson today. You need to conceptually understand this. I can't just like do rules anymore. It breaks my heart. If I walk a city block this way, and I walk a city block this way, and then I realize, crap, I could have gotten there more easily if I had just walked this direction. Then I've made a triangle that, now don't ignore my collection, I'm just going to scroll down to not my dot paper. If this is 1, and this is 1, then this distance connecting them is bigger than 1. And we can actually use some formulas to figure that out. We don't care about that right now, though. All you need to know is don't label that at all. Just leave that. But you should still be able to figure out what it should look like when you scale it up. Just don't label it. Anyone confident enough to come draw our scaled up figure from 300%? Oh gosh, I should use cards. Sorry, not making that choice. Too many hands went up. All right, first card up here. Will, you want to come up? Do you have any interest? If not, just pass.
I'll try.
You want to try? Sweet.
That made your life so much easier.
That's why I have cards. I don't like decisions.
Always take hard.
Can you not shuffle them?
I did
I'm trying to run through the whole stack.
Yeah.
So now I put this at the bottom. And when I am done with the whole stack, that if this stays the bottom, I'll know I didn't shuffle. Which that's my goal. Huh?
No, it's like any
Do I what?
Guys, no squeaking.
It's my system that I've been using ever since like my second year of school. So you scaled it up by a factor of 300%. How did you choose your lengths then?
So what I did is I said that there's 2 up here. So then, if you wanted to do like 600%, you'd have to multiply, or 300.
Okay.
600. If you wanted to do 300% of this, like just the top part, you'd do like basically 2 times 3 equals 6.
So to get from one dot to the next, how many gaps do I travel? 1 gap. So if this, now I know I told you guys to not label that, but this is 1, right?
Oh, yeah.
Because remember, we care about the length of things. Now, like always, if you're done with 41, you can move on to 42, but there are a couple parts to 41. Or, sorry, 4-1, so please keep trying to work that. Who's in your group? Somebody tag me. Did you draw this on your paper first yet?
Oh, I tried drawing it and then I like messed up.
So now take a work with your group. Sorry, I thought you were further along. Grab a seat. You're good, but just work with your group first. You've got a couple misconceptions, and I think doing it on your paper will help. Doing it on the smart board and trying to figure out is not great. Alana, any interest in coming up? Any interest in coming up to draw it? Yeah? Sweet.
Alright, guys. So, if this is 1 unit, we multiply that.
Wait, that's
You didn't do the vertical.
oh,
You were right the first time, actually.
okay.
You got this.
Yeah.
Perfect. So even though Alana doesn't know the length of that original diagonal, she knows it goes diagonally from a point to the next point. So it runs a diagonal 1, whatever that would actually be. We'll call it like 1D, like 1 diagonal. So she makes it 3 diagonals. The distance on the bottom that was 2 gaps, 2 spaces, now became 6. The distance that was 1 vertical became 3. Perfect. Very good work, Alana. So this has scaled up to give us lengths of like 3 and 6 and 3 and 3 And we'll call this 3D, even though it's kind of awkward. And another 6. So when we talk about a scale factor, now you can remember the word scale factor. You don't have to write this, but if you're like me, and you should probably just go ahead and write it, then I'd advise you to write it. I'm just going to go to a new page, clean this up. A scale factor, which we can abbreviate SF, we will a lot of times abbreviate it SF, is found by taking the copy, like the new shape, and dividing it by the original. So here we could take any of those length comparisons, even 3D compared to 1D. But if we take like a 6 and compare it to the 2, we see that every length has, what we already said, been multiplied by 3. So we know 300% really means a scale factor, I normally do all capitals, of 3. So what could we say, I don't know, about like 900%? Oh, you guys all know it, you're just sitting on it. 900%, what would the scale factor be?
18/2.
Well, okay, we could do 8. For this, it would be like 18/2, which would then give us just 9, right? Our scale factor is not a percentage. When you go to a copy machine, it will ask you for a percentage. When you do something on the computer, it will ask you for a percentage. Our scale factor is just a multiplier. So if it's 1.1, hold on, Piper, this is one where I want to see what you think. If our scale factor is 1.1, so what if our scale factor was 1.1? What would that actually mean? Guys, I have extra pencils. Are you seriously sharing a pencil?
No, I just asked for the
Take a pencil.
Whoa, that's
This is not my first rodeo.
That's why I said Kobe.
Hold on.
I think it's 110%.
This means an enlargement, right? Because it's over 1. I can't write today. An enlargement by 100. That's just the original. It only got 10% bigger. A little bit bigger. So what about if I tell you my scale factor is, I don't know, 0.7? What is with all this just reading? Your hand went part of the way up, Naya. So what'd you say? This is 70%. Would that be an enlargement?
No,
That would actually be a reduction. Well, be careful. Yeah. So we would take every dimension and just multiply by 0.7 or 70% and figure that out. So moving forward, in 4-2. Sorry, we can skip the rest of 4-1 because we essentially answered all those questions. So check out 4-2. By the way, if you missed the little notes in your book, every time it shows dots, no, 4-2. Every time you see these sections with the dots in your book, all the dots are equally spaced. The dots will never change sizes. So if the shape changes sizes, it has to take up more dots, right? But we care about the gaps. So it had a little note right here in a box. It said note for all enlargements and reductions and everything, the dots will stay the same size. So work on 4-2 with your team for a few minutes. We'll get back together before we start. I need to get more bags. So you either need to bring a bag in, or I need to go to Kroger, but I've not been to Kroger. We went to Fresh Time and we did not get bags. We took our
Wait, did you get some of that cotton candy?
I didn't go last night. That's just we prefer to shop at Fresh Time if we can. For what? I like the fruit sales. They have like 77-cent fruit sales. It's like a pound of fruit for 77 cents. That's crazy. What? Oh, I'm so gonna find that the next time I'm there. I'm gonna have to like look on the low shelves.
Yeah, you get like
I don't shed too much for service though. So like grocery bags are great. Yeah, just if there's a few extra to make people replacement covers, that'd be sweet. Thank you very much.
My mom, she's like, plastic bag for the environment.
Oh, totally. We only use plastic bags to pick up our dog's poop. I mean, it's better than paper. Annie! Hi. What does a scale factor, or some people will even say it weirdly and say like an enlargement factor of 50%? Like, what are we really doing? We're shrinking it down. Now be careful. So if you say cut it in half, be careful. Because if I'm a literal person, I'm gonna. What are we cutting in half? Hold on. We're using cards. Amy's cards. Every dimension, right? So I agree with cut it in half, but the it has to be the dimensions as we work through it. Here's the cool thing about reductions. You can make them inside of the original. Because if this starts as an original length of 2D, what's the new length going to be? 1D, right? There to there. If this is 4 straight, what will the new one be? 2. Right there. If this was too tall, what's the new one? 1, then 1, then 1, then 1, then 1, then 1, then 2. Woo! And that's how we do a reduction. Why should I up there? Up? Why up and over?
No, not up and over. Over.
Just over? Why?
Now it looks like a crown.
Because it's not all attached. That's the other hard thing. Now it's all attached. We want to move it like there. Why there?
Why there?
That's gross.
It looks like a smaller version of the thing now. That's like earlier.
Okay, wherever you put yours, just make sure all your dimensions are half of what they were. Yeah, let's move on. So, hold up. This is one where you choose. Now you have starting dimensions of 1, a very awkward diagonal, a vertical of 6, horizontal 3, vertical 3. So decide with your team what you're going to do to choose a scale factor and make a new one. Now my challenge would be, and I think we have enough time to do this, can you make one version of this clean enough that you can trade it to another group and have them try to determine your scale factor? So try to make one of these clean enough, one of your papers, and trade it to another group. Take 2 minutes to make your new shape. I'm kind of merging parts B and C. You can choose whatever scale factor you want. Or make it smaller. You guys decide. You choose your scale factor.
Oh, I'm gonna make it bigger.
Why are all these images terrible?
Because they're not
I had a decent one.
It also
There we go. Good enough. I know. So check this out. I want to show you how isometric dot paper works before we get out of here because I think it might grab your interest. So isometric dot paper guides you into drawing in 3 dimensions. So if I want to draw a square, I can draw a square connecting some of these dots. Right, but then the other ones, like every other line does line up. But then if I start to connect some of these in a similar fashion, I can use this to create depth. And if I change colors and go a different direction, I could show different depth. Actually, that one I broke. I broke that one somehow.
Yeah.
No, this one. There. Sorry, get rid of that one line. No! No! But, so if you want to grab a sheet of isometric paper, it is there to help you, guide you into 3-dimensional drawings. And feel free to play with scale and everything else on that as well. That is all the time we have for today. You should be fine to do your homework. We're going to breeze through the rest of this lesson really fast tomorrow. We're going to start with trading those papers to see scale factors. Okay, we're going to start with that. We will take your test. I'm still trying to decide how long I think it'll take, but I'm thinking probably team test Thursday, like individual assessment Friday. If we don't get done, we don't get done, whatever, it's okay. So plan on team test Thursday, individual test Friday, so math journals turned in by Friday. Okay, thank you guys very much. Have a great day. Questions? Yeah, so we just literally move faster through the content. You skip stuff strategically. Yeah, so you can always see what they're doing. But like, really, we do the same stuff. You guys just have to learn things more quickly and with less instruction. So like, I don't this year. Here, check this out. If you're curious, so this is what it looks like to merge to make accelerated 7 out of math 7. So this is the math 7 content. We skipped. Then we skipped 3 in a row. So this is how we get ahead by skipping strategic.
Okay,
Skip
but
4 lessons in a row. Like, yeah, that's why we're jumping through the text. That's all. If you ever want to know where you're going, I mean, this is you can access this information. What's that? For similar figures? Oh, for finding the angle or finding the distance? Yeah, so are you talking like Pythagorean theorem method or what? Yeah, Pythagorean theorem is more of a Math 8 standard.